Hello class, Professor Anderson here. Let's talk about forces and see if we can make some assumptions about what they actually do. All right? We talked a little bit about forces, gravity, electromagnetic force, tension, friction, so forth. What do forces do? Let me ask you guys this question. What do forces do? Yeah, Sean.
Forces cause motion.
Forces cause motion. All right? We said that everything is in motion in the universe, and there must be something governing that motion. So maybe it's these forces that are causing motion. Any other ideas? Yeah, Chris?
Does force cause pressure too?
Force can cause pressure. Absolutely, right? We are under pressure right now. Why are we under pressure right now? Probably because you have a midterm coming up in another week or so, right? But more specifically, we are under pressure from the atmosphere, right? There is something called atmospheric pressure, which is all the air above us pushing down on us all the time. And you don't really notice it unless you do a couple things like go up in an airplane or go up in a mountain, go up to the top of a mountain. You can feel that pressure change. Or if you go underwater, you can also feel that pressure change. So pressure is certainly related to force. What else can we say about what forces do? Somebody over here had a comment? Yeah, Martin, what do you think?
I think in the most simplest terms, it keeps things together. It holds stuff in place.
Keeps things together. All right. I think that's a great notion. Right? Atoms, we know, are protons in the center, electrons in the outer ring, and those things are held together by forces, right? Specifically electromagnetic forces. If those forces don't exist, then the electron just flies away. We don't have any atoms anymore. We don't have you. We don't have me. We don't have our universe as we know it. So forces are responsible for keeping stuff together. Absolutely. All right, I like all those answers. But let's focus on one, which was force causes motion. Okay, somebody said force causes motion. And the reason you might say that is because when you run out of gas in your car and you got to push it to the gas station, you get behind the car and you apply force to it and you get that car moving. Your force causes motion. But that's not quite specific enough for our purposes. What we want to say is the following. Force causes acceleration. Okay, this is the really key concept. Force doesn't just cause motion, it causes something called acceleration. We know a little bit about acceleration. And specifically, when we talk about force, we want to talk about the net force. The net force is written like that. This is the summation sign from mathematics. And it says you have to add up all the forces that are acting on that object and see what the net force is on the object. And if the net force is equal to 0, then the acceleration A is equal to 0. Okay, so this is kind of a weird concept, but if you're driving your car at constant velocity, okay, you're driving down the freeway in a straight line at 60 miles per hour, what's the net force on your car? What do you think? Samantha?
0.
0. Why is it 0?
Because
force is mass times acceleration, so if you're not accelerating, then there's no force.
That's exactly right. Force is mass times acceleration. If you're moving at constant v, what is your acceleration? 0. So the net force is equal to 0. You go, well, wait a minute, that doesn't make sense, right? I know that when I step on the gas, I drive at 60 miles per hour. I have to keep my foot on the gas, right? If I take my foot off the gas, I slow down. Isn't that applying a force? I mean, I'm pushing on the accelerator, okay? And it's not directly that force that drives the wheel, of course. That lets more gas into the carburetor, which goes into the pistons, fires up, creates these little mini explosions, right? Piston gets pushed down, cranks on the crankshaft, attaches to the wheels, pushes on the wheels. There's friction between the rubber and the cement. Coefficient of friction is about 1.0 for rubber, right? All that translates into a forward force driving your car. But we just said the net force is 0. So what's going on? Yeah, Sean.
There's a constant force of the friction on the road and the air resistance pushing against the car.
Aha, we have to include all the forces. Good. So let's draw a picture of our car. Here's our car. Okay, I don't know what brand of car that is, but that's fine. And now we're heading down the road at constant V. What are the forces that are acting on this car? Well, the way we picture force diagrams is with something called a free body diagram. I change my car to a dot and now identify the forces that are acting on the car. There's a force pushing it forward, which is the force of the engine acting on the drive shaft, acting on the wheels, acting on all that stuff. And so this is the force, we'll just call it the force from the car itself. But Sean said there's also air resistance, which is the opposite direction. Right? When you drive your car down the road, you have to push a lot of air out of the way. And you don't get to do that for free. It takes a lot of force to do that. The more streamlined your car is, the easier it is to do that. If you have a big truck with a big flat front on it, like a semi-truck, you push a lot of air out of the way. That force can be very big. Is that it? Are those the only two forces acting on the car? What else do we have?
Gravity.
We have gravity. Okay. Gravity, you already know, points down. And is that it? Christian, what do you think?
You have the contact path creating friction from the rubber to the road.
Okay, we have some other frictional coefficient, which is going to oppose our motion. This is friction. We'll write that with a lowercase f. There's some friction in the rolling motion of the tires, right? Ball bearings are in there that are actually sliding between metal plates, and those things have some internal friction. Is that it? Is there anything else acting on the car?
Normal force.
Yeah, in the back?
The ground pushing up.
The ground pushing up, right? And that's what we call the normal force F. So, our very simple question here, the net force is 0, is actually pretty complicated. These are the forces that are acting on the car, and if we add them all up, they're going to add up to 0. Okay? And this is the concept that we're going to develop in this chapter and the next chapter, is this idea of adding up forces, which are vectors, and making sure that their sum is equal to the mass times the acceleration, and then we can solve for things like the acceleration. Okay, let's talk about something else.